Greetings, this is Jim. If we've spoken in the past few years, I've probably talked your ear off about programmable money, smart contracts, and stablecoins and tokenized deposits. So I thought it was just about time that I do a technical walkthrough. I'm going to do a hands-on Solidity walkthrough using a transaction and a mythical coin called the Copernicus coin, or COP as it's identified in the demonstration. Before we get started, I just want to do a disclaimer. If you have a feel for stablecoins, tokenized deposits, and smart contracts, that's really going to help, but you do not need to have any technical knowledge of programming or the language Solidity. It is going to get technical because this is a technical dive. So we're going to use Remix. Remix is what's called its integrated development environment. It's free, provided by Ethereum, and that's where I develop my smart contracts. That's what I'm going to use for the demonstration today. It's really cool. Follow the balances and receipts, not the code that make it happen. We're going to take this one step at a time, and I will click through each step. I'll explain the step. So it's going to take a bit of time. I'm going to be doing some typing, but keep in mind, in production, systems pass the values I'm going to type automatically. We're going to be using test accounts only, so there's no problem sharing this video with others. And remember to pause and send me your questions too. All right, let's jump into it. We have three actors in our story. The bank. They're going to hold tokenized deposits. They're going to mint our COP, and they're going to administer our escrow and Oracle controls. Our customer who holds the COP in a wallet or an app, they're going to authorize payment to a merchant for a purchase of some merchandise. Our merchant is going to be paid from the escrow after proof of shipping is verified. And ultimately, they can burn to redeem that COP for fiat anytime that they want. Before we dive into the demonstration, I think it's important to cover four key concepts around smart contracts. First of all is inheritance. So this code inherits the ERC20 standard. That means that rudimentary functions such as moving tokens between accounts or getting balance on accounts are already pre-written and pre-tested. Next is state. This is key because I can see the state of any one of the components of the smart contract. I can see the dollar value of what's escrowed, for instance. I can see if the shipping tracking number has been confirmed. And this way of monitoring state allows to make sure that we're on track and we're not missing any steps in the life cycle. Next is event. Our compliance and auditors love this because every single function that's performed within the smart contract is fully auditable. And I'll show you an event in the demonstration. Last is rules. We baked rules into the code so you can see in this particular function. This is about as technical as I'm going to get. Here's a function called mint, which is going to mint our Copernicus coin. And I just require that the amount is greater than 0. So that's pretty logical. This particular piece of code is not safe. I have some rules written in here that are overly simplified for demonstration purposes, but rule sets can be very complex. All right, let's jump into the demonstration. Now we're on to the heart of the walkthrough. We're going to cover a complete life cycle of the transaction. We're going to start by minting our tokens in this account here on chain. That's our customer account. We're going to mint the US dollar equivalent of $300.29. That represents 30,029 tokens because on chain, we have to represent values as unsigned integers. So let's execute the transaction in our simulated environment. As we step through the life cycle, we'll see that the customer now has $300.29 equivalent in COP in their account. So let's go into our live environment. We're on Remix. We're live. I've just compiled. VerifiedPayment is our name of our contract. And let's go ahead and deploy our smart contract. We can see the address in which it's located is here. We're going to run our first function, that is mint. So we're going to paste in our long hash account number here for our customer, and we're going to put in 329 cents. and we'll transact. We'll see that as confirmed, but let's take a look at an ERC20 function, balance of, where we can confirm the balances in the account. And there it is, 30,029 tokens for US dollar equivalent of $300.29. Okay, let's go to the next step, and that is to authorize a payment from our customer's address to our merchant's address for the full value that's just been minted. And there is a new order number issued by the merchant that we're going to use for tracking, and that is ORD-7781. We'll execute this transaction. Nothing happened to the value in the customer's account because we haven't funded the escrow quite yet, but it has been authorized. That's the status after we're done. We'll go into our live environment and we'll go ahead and authorize that transaction. We'll pull down authorize here as a smart contract function. We'll put in all the particulars here. We're going to grab the merchant account from here. We have to do this copying, pasting, because we can't memorize these long hash account numbers. We're going to put in the full value here. That's what we paid our merchant for our valuable merchandise. And we're going to put in that order number, ORD-7781. Go ahead and transact. And now we're going to look at our balances on our accounts. The balance should not have changed, right? In our simulated environment, I showed you that we didn't fund the escrow yet, but we'll confirm it's confirmed live that the dollars and cents are rather our tokens are still in the account. I want to show you another ERC20 function where we can get the current state of our orders. Now, if we put in our order number we've just created, we can pull it up, and here is the current state. We can see the customer address, we can see the merchant address, and we can see the amount. And soon we'll have the tracking number included. Let's go back, and the next step is fund our escrow. So we'll move 329 into our escrow, and let's go ahead and do that. We'll see that our customer's account should be zeroed out, and our smart contract escrow should include $300.29 equivalent. Let's go back to the live environment and perform this function. So we'll find the function, fund escrow. We'll put in our order number, which contains all of the particulars to make this possible to fund the escrow for the full amount. We'll transact. We'll go ahead and verify all of our account balances to make sure everything moved appropriately. Let's go to the balance of, and that is our customer account number. We'll see that is zeroed out. You may ask, where did it go? As I mentioned, it went to the smart contract. We'll copy the smart contract address. We'll paste it in. And we'll see that the escrow inside of our smart contract now contains the 329 equivalent. The other things that I wanted to show you is how we can expand events. So I mentioned events in the introduction to smart contracts, and let me show you. So when I push that down arrow inside of Remix under Fund Escrow, I get a full audit log here of the transaction. Auditors love this. All right, let's go to the next step. We'll go back to our simulated environment. The next step is to request shipping verification. So let's go ahead and perform this function. We'll see a verify is requested. Let's go back to our live environment and perform the same transaction. So we'll request shipping verification is our next step. We'll put in our order number, and we'll put in our tracking number. Where's the tracking number? The tracking number here is this package 1042 that was generated. Here is our package number. Think of a FedEx shipping number as the equivalent. So we'll put in our packing number here. This is how we verify delivery. We'll go ahead and get that established. That is all set. Notice that when we go back to our ERC20 function called orders and we recall it, we're going to see the package number here. So the current state of our order now contains the current updated package information. All right, the next step in this process is an oracle call. Oracles provide trusted information based on an outside source to the on-chain smart contract. I've simulated it here just for the sake of ease and simplicity. Our mythical server comes back with a message here. I supplied the tracking number, which is PKG 1042, and my package delivery service said that's been issued, returning a Boolean value of true. So that's how oracles work. Let's go back in and simulate that our oracle made the call directly to Chainlink by performing the following function. We're going to actually confirm tracking is issued. But before we do this, let me try to break our smart contract. Before we confirm shipping, let's go ahead and try to just release the money to our merchant. So this is where we're going to release our escrow. That's $300.29 to our merchant. But we're doing that before we've actually finished our oracle call. So let's put in our order and see what happens. And what we get is an error as we expected, and says tracking is not confirmed. So let's go back and finish up our oracle confirmation here. We're going to confirm the tracking is issued. And it came back true. That's how it got confirmed. Now when we go to release our escrow, we're jumping ahead of our virtual environment now. No big deal. When we do this now, we're going to go ahead and release the money from the escrow inside of the smart contract, and that's going to be put in the hands of our merchant. So let's confirm that that was done. Let's go look at the balance of our merchant. I'll grab the merchant information. We got to catch up over here. We'll go ahead and release our dollars. We'll see the money in our merchant's account here. We'll copy their account information while we're over there. We'll paste it in, and we'll see that the money is in the account. We'll confirm that it's been moved out of our smart contract. We should see 0 inside the smart contract. The last step in the process is just redemption. Our merchant can redeem those Copernicus coins for US dollars if they ever want to, but they can continue to hold Copernicus coin. As I wrap up, I just wanted to thank you for hanging in there on this technical deep dive into smart contracts and programmable money. If you know someone that can benefit from this type of programming, please give it a share. And if you have questions, please reach out. Have a great day. Talk soon. Bye now.